When dealing with service entrance conductors for a large commercial project and considering the use of 90°C rated conductors from a power company pad mount or secondary termination cabinet, understanding the temperature rating of the power company's secondary lugs is paramount. The secondary termination cabinet's lugs are rated for 90°C according to the manufacturer. However, the temperature rating of the lugs at the power company pad mount is not universally standardized. It varies depending on the utility company's specific requirements and practices. There's no single answer that applies to all situations. Therefore, the most direct and reliable method is to contact the utility company directly. Inquire about the temperature rating of the lugs they use at their pad mount transformers. This information is essential for ensuring that the entire system, from the pad mount to the secondary termination cabinet, is compliant with safety standards and electrical codes. The National Electrical Code, or NEC, provides guidelines for conductor ampacity and termination temperature ratings. It's crucial to adhere to these guidelines to prevent overheating, insulation damage, and potential electrical hazards. When selecting service entrance conductors, you must consider the lowest temperature rating among all terminations in the circuit. If the power company lugs are rated for only 75°C, even if the conductors are rated for 90°C and the secondary termination cabinet lugs are rated for 90°C, you must use the 75°C ampacity for the conductors as specified in NEC Table 310.15b16. This is because the termination point with the lowest temperature rating becomes the limiting factor for the entire circuit's ampacity. To determine the appropriate conductor size, you need to know the calculated load for the service. This calculation involves considering the connected loads, demand factors, and any applicable diversity factors. Once you have the calculated load, you can refer to NEC Table 310.15b16 to select a conductor size with an ampacity that meets or exceeds the calculated load, taking into account the termination temperature limitations. Consider a scenario where the calculated load is 400 amps. If the power company lugs are rated for 75°C, you would need to select conductors with an ampacity of at least 400 amps at the 75°C column in NEC Table 310.15b16. This might require using larger conductors than initially anticipated if you were only considering the 90°C rating of the secondary termination cabinet lugs. Furthermore, the type of conductor insulation also plays a role. Common conductor types include THHN, THWN, XHHW, and others. Each type has different temperature ratings and suitability for various applications. Ensure that the selected conductor type is appropriate for the installation environment, considering factors such as moisture, temperature, and exposure to chemicals. The NEC also specifies requirements for conductor installation, including conduit type, full capacity, and support methods. Adhering to these requirements is crucial for ensuring the long-term reliability and safety of the electrical system. When contacting the utility company, be prepared to provide them with the project details, including the calculated load, the location of the pad mount, and any specific requirements or concerns you may have. This will help them provide you with accurate and relevant information. Also, document all communications with the utility company, including the date, time, and the name of the person you spoke with. This documentation can be valuable for future reference and for demonstrating compliance with regulatory requirements. Remember that electrical work can be dangerous, and it's essential to follow all safety precautions and regulations. If you're not qualified to perform electrical work, hire a licensed electrician who has experience with commercial electrical installations. They can ensure that the work is done safely and correctly. In addition to the temperature rating of the lugs, also inquire about any other specific requirements or restrictions the utility company may have regarding service entrance conductors. They may have specific requirements for conductor type, size, and installation method. Understanding these requirements upfront can save you time and money in the long run. The utility company may also have specific requirements for the grounding and bonding of the service entrance equipment. Proper grounding and bonding are essential for electrical safety and for preventing electrical shock hazards. Ensure that the grounding and bonding system is installed in accordance with the NEC and the utility company's requirements. Furthermore, consider the potential for future expansion or changes to the electrical system. It may be wise to install larger conductors than initially required to accommodate future load growth. This can save you the expense and hassle of upgrading the service entrance conductors later on. Also, consider the coordination of overcurrent protective devices such as circuit breakers and fuses. Proper coordination is essential for preventing nuisance tripping and for ensuring that only the faulted portion of the circuit is de-energized in the event of a fault. Work with a qualified electrical engineer to design a coordinated overcurrent protection system. Another important consideration is the accessibility of the service entrance equipment. The equipment should be readily accessible for inspection, maintenance, and repairs. Ensure that the equipment is located in a safe and dry environment and that there is adequate clearance around the equipment for working space. The NEC specifies minimum working space requirements for electrical equipment. Be sure to comply with these requirements to ensure the safety of electricians and other personnel who may need to work on the equipment. Also, consider the potential for environmental factors to affect the service entrance conductors. If the conductors are exposed to sunlight, moisture, or extreme temperatures, select conductors that are specifically designed for those conditions. The NEC provides guidance on selecting conductors for various environmental conditions. Remember that electrical codes and regulations are constantly evolving. Stay up to date on the latest changes and revisions to ensure that your electrical installations are compliant. You can subscribe to industry publications, attend training courses, and consult with electrical experts to stay informed. In summary, determining the power company lug temperature rating is paramount. Contact the utility, understand the NEC, and prioritize safety for a successful commercial project.